Hello, welcome to the latest episode of Data Unchained. I'm your host, Molly Presley. Before I introduce today's guest, who has if you're on video, you probably recognize him, but I'm going to wait just a minute to give the formal introduction. I'll talk a bit about this podcast. Data Unchained was created on the premise that data has become increasingly distributed, thinking back to the days where data originally was kind of designed to be generated in the same building in proximity to like a mainframe computer. The people, the applications, the computer systems were all in one place. And now, as we all know, the world is creating data everywhere. And there's a massive interest in putting that data to work, whether it's for AI or data analytics, companies or country sovereignty, all those different areas. So what Data Unchained touches on is what are some of the challenges in taking advantage of this decentralized data? What are some of the business opportunities? And then today we're going to talk a little bit more on the infrastructure side on some of the challenges that our industry has fallen into this year. So without further ado, I'm going to introduce Tom Coughlin. He is the president of Coughlin Associates, which does a lot of different things. And he was the 2024 IEEE president. Tom, welcome to the show.
Thank you very much, Molly. I'm glad to be here.
Tom is the president of Coughlin Associates and was the 2024 IEEE president. So he has great industry experience as well as a lot of data in this space that we're excited to walk through today. Before we do that, though, Tom, can you talk about in a little bit more detail about what your role has been in tracking technology, some of the research that you put out into the market?
Sure. So first of all, I've been involved in the storage and memory industry for over 40 years. And, I've worked at companies for many of those years as an engineering manager, executive. And more recently, about the last 25 years, I've had my own company. And I have put on storage memory-oriented events. In fact, I'm currently the general chair of the FMS conference, which is the Future of Memory and Storage. It's going to be in August in Santa Clara Convention Center, Santa Clara, California. And I've also write reports on digital storage technology and applications. I do one with a colleague on emerging non-volatile memory technologies, another one on digital storage in the professional media and entertainment industry. I have a newsletter as well. I write for Forbes.com on storage and memory topics, and then I do many different types of consulting activities I've done over the years, both technology-oriented and business or things with VCs and various other and startups of all different types, if it's involved in storage and memory.
So you're prolific as a thought leader and writer for sure. For those of you listening, we'll put in the show notes some links to some of this content so to help you find the FMS event, some of Tom's latest research. So we'll make that easy for you to find and you can look there. Before we jump into the show, talk a little bit. FMS used to be called the Future of Memory Systems, I believe is what the MS standard
No, it was Flash Memory Summit.
Flash Memory Summit. That's right.
Yeah.
And now it's been rebranded over the past couple of years to talk about storage more broadly. I mean, both you and I are pretty heavily involved in that event. It would be great to talk a little bit about what it will be about this year. I know planning is just getting underway.
Sure. It's going to be focused on some of the big things that are going on in storage and memory space, all the different technologies, whether it be DRAM, high bandwidth memory, NAND flash, hard disk drives, magnetic tape, optical storage, DNA, you name it, plus, ways in which it's being used in things. And one of those, of course, a big driver to for this year in particular is artificial intelligence and all the ramifications to do artificial intelligence, where essentially data is the fuel that the artificial intelligence engines run on. And data lives in memory and storage. Getting that data to AI is important, and having enough storage and memory to provide all the resources that AI needs, either for training or inference, are very important. So that's an important theme. But there's other interesting things too. There's some interesting activities going on with data centers in space. outer space of various types been going on. It's still early days, but I think that's another possible interesting topic. And there's I mentioned just earlier, but there's new memory and storage technologies. There's startups actually, for instance, in the optical storage side, DNA and other approaches as well. So it should be a very interesting conference, looking at all the options and the ways in which storage and memory are being used to make modern life possible. It's
pretty interesting, and I feel like we all say this, but for this event as well, the innovation pace is absolutely breakneck. It used to be that each year things were incrementally different. Now it's a whole realm of new technologies, new use cases, data centers in space, data centers underwater, in lakes and oceans. I mean, all kinds of wild stuff. Yeah. So definitely we'll provide a link there and talk further at that event about some of the topics from today. So let's talk about what brought us together. I was really excited to get you here as quickly as possible on the show, related to this NAND shortage that has hit our industry. Maybe you could talk about, I know you've written a couple of reports, you're in the process of publishing some data on this. What are you seeing as the current situation with shortages that are occurring because of the NAND shortage?
Well, NAND, DRAM, hard disk drives, they're all in short supply. Basically, any type of memory and storage. What's happening is we're ending up with contracts, especially with big customers like the hyperscalers, and where they're going out even to 2027, in terms of their orders with manufacturers. The DRAM folks, consumer side DRAM is suffering because a lot of DRAM is being, where a lot of the DRAM that's capable is being used in high bandwidth memory, which has a higher margin, right? And demand is very high for that, especially to support GPUs and AI workloads. So basically everything's in short supply. It takes longer to increase supply than the rate at which demand can change. So it tends to lead in some of these areas into like a sort of a boom bust economy where times are good or times are not so good for the memory and storage manufacturers.
And I think it would be worth mentioning or talking through why is it not easy to just, it's not like printing money where you just print a bit more money today. There's complexities to that too, but what makes the supply change difficult? Why is it such a long lead time?
Well, if we focus on the solid state memory and storage technologies like DRAM and NAND flash, basically those are expensive plants. The fabrication plants to build, like the 3D NAND plants, could be like $15 billion to build a new plant. And it probably is going to take 18 months or more to come online. So when you make the investment to build new capacity, the time it takes for that new capacity to come online is quite extended. So the supply, the ability to adjust supply to meet exceeding demand, right now, demand has increased much faster than the supply has been able to. And the other factor in that is that actually 2022, 2023, we had the opposite problem for these companies in that nobody wanted it. The supply was so much greater than the demand that, in fact, for instance, some of the NAND flash manufacturers cut their production by 50%, which they never do because it's such an expensive plant and they want to amortize the cost. They run full out generally, but they actually cut for a while their manufacturing capacity by 50% because demand was so low and the prices were going below the cost of manufacturing. So that's what I mean. It can be a boom bust cycle, and so that and also that's cautionary for the manufacturers in that they know this too shall pass, right?
Absolutely.
Good times won't last forever.
Absolutely. I've thought about that some of them probably are wishing they had just kept building and stockpiled a bunch of inventory during that time frame. But that may not have worked because the form factors and capacity points changed so fast that some of those SSDs, when they weren't in high demand 4 or 5 years ago, wouldn't be what they need now anyway.
Well, and the big issue was during the COVID times, people were expanding data centers to support remote work. And it was also the supply chains are severely disrupted because of work interruptions. And so people had huge inventories of these products coming out of 2022 or coming out of the COVID. So in 2022, and then even worse in 2023, there was all this inventory. Nobody bought. People did not buy much new capacity, and that's why there was this. There was a glut.
Yeah,
but then,
absolutely.
More recently, we've seen that inventory has been burned off, say in 2024, and then 2025, 2026, we've had this huge increased demand to support all the AI stuff that's going on.
So based on your research, what type of data do you feel comfortable putting out there on lead times, how much pricing has changed? Is there any data that you'd like to share from some of your recent research?
Yeah, some of the things I'm hearing is that, NAND flash and DRAM have had very, very high increase in prices. In fact, compared to hard disk drives, NAND flash SSDs now are considerably broadened in terms of how much more expensive in dollars per gigabyte flash is than hard disk drives. And so this kind of goes against the activities that the NAND flash SSD guys are doing with QLC flash products with like 250 terabytes or more capacity, that they hope that they could, they have an advantage over the hard disk drives, are able to drive down their prices. This sort of works against that. The hard disk drive prices have increased as well, but not as much as the NAND flash. I've heard some like 80% price increases that occurred last year, for example, with SSDs or more, even 100% or more.
Absolutely. And I've heard numbers up to even 6x increase depending on the type of SSDs when you're hoping to achieve delivery timeframes. That I've heard numbers like you're saying that are more conservative, like 25%. I've heard 6x. I've heard all over. Yeah.
I heard 16 times some
Did
for
you?
some some NAND flash cost per gigabyte or terabyte versus hard disk drives. It depends, and you have to look at the application and, do an apples to apples comparison on these things. But yeah, it's, everything has gone up in price. All the storage and memory guys are having great revenues right now.
So a bit of a caution to the listeners. I think that just given that we can't even give you a hard data point on what you'll pay or what the price increase will be, and none of the suppliers can, including those who manufacture the SSDs, certainly check your quotes. How long do those quotes remain valid? I think a lot of these vendors are requoting weekly, even a little bit, even sometimes shorter timeframes than that. So the quote you have, make sure you check that it's valid when you're ready to pull the trigger on a purchase, just so you don't get caught by surprise. And then I do want to talk about the workflows a bit, but I also want to talk about the lead time piece. So I know that the hyperscalers are consuming a lot of the demand. Mm-hmm. Are you feeling that most companies, smaller enterprises, things like that, are able to secure demand, or are they at risk of even being able to get SSDs?
Well, there's certainly a danger that if some of the larger customers have contracts going out even to 2027, which probably have some limitation on price increases and quantities, that depending upon the ability of the suppliers, the memory suppliers, to be able to increase their capacity to meet other demand, they may get squeezed.
So let's talk about what's caused this. Is it that the silicon, the NAND, is going into compute and memory and storage is getting left behind? Is it that there's a lot more data being generated? What's your perspective on what happened that led us to this moment?
Basically, AI is a voracious eater of memory and storage. And so all the memory and storage technologies are being buoyed by this. And in fact, even some of these new non-volatile memories, I think, are getting more interest in them, in developing them as a possible replacement for, say, DRAM or other memory technologies. Whether that's successful or not is another matter, but, there's a possibility there. And of course, I said there's a colleague and I, we do a report on those emerging non-volatile memories, which could have other advantages in that, again, this is nothing's going to happen right away, but DRAM uses up a lot of energy because it has to be refreshed. And if you had a non-volatile memory that could have the same speed, had comparable prices, then I could save an awful lot on the total energy. And, the high bandwidth memory with DRAM is a big part of the cost and the operational cost on these GPU systems. So, it's certainly, we've gotten a lot more interest both in the market and on the technology side, and all of the memory and storage technologies that are out there. I think they're all being buoyed by what's going on.
Do you have some guidance on what customers should do with their workflows? Like, where might they find some available SSD capacity? How might they more optimally use them? Any guidance in that area?
Oh, yeah. I think that especially in times like this, looking at what can you do with what you've got? What can I do to extend its life or to extend its usefulness? And I think of some, general ideas that, and the other part of that is, how can I avoid moving things around, right? So one of those is, how many copies of content do I have? Can I do any kind of a deduplication or any technologies that can help me on that? Another one is compression of data, so that I can get more data. There's some overhead involved in that. But if I'm willing to deal with that overhead, then I could have more data in a given amount of storage capacity. So there's things you can do on that side. There also is stuff that's been going on the software side, and also with some of the manufacturers, that if as parts of a storage device fail, that I can continue to use it. And so I know the hard disk drive guys and the SSD guys as well are doing things that could extend the life of these products. Even if I start to get some issues with it, if it's not a fatal issue, that I can continue to use it at, a degraded capacity or performance level to the extent that I can.
As customers are looking at the hyperscalers and how they use them, they may have capacity, even if they can't buy them in their data centers, that maybe they burst up to the cloud for capacity in ways that they ideally weren't for a while, because maybe they were moving off the cloud or whatever their organizational direction was. But I think always looking at what the cloud has been able to secure and integrating that in your workload might be necessary this year just to get access to that capacity.
It could be, especially if these hyperscalers, who you generally would use for many of these cloud services, have better access to the storage and memory, that that may be the way that you temporarily augment whatever your local capabilities are.
Yeah, absolutely. At Hammerspace, who I work for, as probably most people know, we saw an interesting deployment recently of an inference workload that was going to be too expensive to go buy the SSDs for. And they leveraged Oracle Cloud to not just use their GPUs, but the NVMEs that are attached to those GPU environments are a part of those GPU nodes. We call it tier 0. Other companies call it like hyperconverged or something like that. But they wanted to get access to the NVMe in the GPU nodes as a way to find available capacity without having to go buy more. And Oracle was able to present that to them, which I thought was pretty interesting.
Well, and that brings up the idea of pooling, or, basically disaggregating storage or memory components from individual servers or individual applications to the extent you can, putting them as a resource in a pool, whether it's a virtual pool or a physical pool, and then being able to allocate the elements of that pool using software to support whatever workloads you've got. So that's another approach, because as you point out, you can have DRAM in a server that's basically, it's trapped, whether it's being used or not. And this might be a way of liberating, either by virtual pooling with a server, or by physically creating, say, a CXL or some other kind of pooling technology to be able to bring those resources available more effectively for where they're needed and keep them in constant use. Another way of getting more efficient and effective use out of the resources you've got versus trying to buy new resources. Different
technologies, global namespaces, all kinds of things to consider and potentially put into place that you might not have for other architectural reasons. But today, those are things to go back and take a look at, along with compression, dedupe, copy management. And I'm repeating some of what you said just because I know people are really hungry for what do I do? They're interested in the data and what should they do? Because, the AI buzz is not slowing down. The desire to put it to work in enterprise was already complicated. People trying to figure out the technologies, the strategies. Now they have a supply constraint on top of it. I think administrators are kind of pulling their hair out. So I want to make sure we're being as helpful at the types of things to look at as possible. One area of your expertise I wanted to delve a little deeper into, and you know as much or more about this than pretty much anyone I know, the change in capabilities of these devices, hard drives and SSDs. we've spent a lot of time looking at capacity, durability, speed, and there's been kind of a trend towards more and more SSDs relative to the number of hard drives. Where can you put hard drives in these workloads that they'll be just fine or good enough? Kind of getting past the hype of go to the SSD, and really a hard drive would work just fine. Kind of what's your perspective there?
Well, there's an advantage on the capital cost, buying hard drives versus SSDs. They're lower cost per dollar per terabyte. But the other thing is the total cost of ownership. And it all depends on what you're doing. If you're actively moving data around, SSDs have the performance that supports that. So they tend to be used for what's often called tier one storage, which is what's directly feeding the servers or feeding the feeding the HBMs and the GPUs, for example. But then there's another tier of storage, which is emphasizing the cost of storage. There's data I want to keep, but I don't need the performance. And so hard disk drives have lower cost, but slower performance. And they tend to be used in the secondary storage tier. So I think that both can play an important role. And I think with the demand for both the short-term memory and the results of a training or the training data itself need to be kept for longer periods of time for transparency, for dealing with potential liability issues, but also to be able to retrain, that you're going to want someplace where you can keep that content, the old logs, the old training data, all this stuff in a lower cost storage for the long term. So there's value for both. They both have their uses, and since I believe that the price of SSDs has climbed even faster than that of hard disk drives, there's maybe more incentive to consider having some hard disk drives at least as part of your secondary storage in your storage infrastructure.
It's interesting. I was just on a Tech Field Day event before you and I chatted. And they were, and with Steve Foskett and that crew.
Oh, yes.
And the conversation came up about essentially tiering, going back even longer ago, data lifecycle management. A lot of that was a lot more around just saving the data in the appropriate cost tier. Mm-hmm. But now when you think about how AI workloads work, when it's time to do a job, you want those GPUs are still more expensive than everything we're talking about on the storage side. Mm-hmm. You want those GPUs fed as quickly as possible, and being able to get the data to the fastest tier, the fastest storage to keep the GPUs busy when you need to, still very important. But then getting it off as quickly as possible, so other data can sit there, I think is going to become really urgent. And where before it maybe was kind of a nice to have, and as the cost of storage came down, people got a little bit more lackadaisical about tiering because the overall cost per capacity had gone down across everything. Mm-hmm. Now it's shifting again. You talk about the cycles of our industry. This tiering idea, or the idea of moving data to very fast storage and getting it out as quickly as possible, I think is going to be a key architectural component we're going to be talking a lot about.
Yeah. In fact, we may end up with even more tiers. Mm-hmm. There's at the FMS last year, there was an announcement by SanDisk that they're working with SK Hynix on developing a high bandwidth flash module that would supplement the high bandwidth memory module with DRAM, mm-hmm. With GPU to be used with GPUs. So we could have even more tiers of memory and storage. And at the NVIDIA at the CES talked about storing, basically it's a key value store for context data from inference sessions that you need longer term storage so that you can use that for continuous learning and adaptation of the training to meet the needs of the person that is interacting with it. So there's this whole context memory storage technology that they were talking about, and the possibility that could add another 100 exabytes or so of data capacity needs to be able to do better inference with this. And that could be SSDs certainly, but perhaps even some hard drives as part of that as well. So there's whole new categories of memory and storage that are developing around the needs for AI and other types of processing.
So I'm going to ask you to get your crystal ball out for just a minute, and we'll talk about the future for a bit. Best guess, how long do you think these shortages will last?
There's kind of a 3-year or so boom bust cycle that's been more or less true of DRAM or NAND flash. It ran into some aggravators at COVID, and then the shortages after COVID, and then the AI boom. But I think it looks like, we could have continuing shortages and price increases well into 2026. I'm guessing by 2027, there might be some pullback from that of some kind. So that's kind of my current thoughts on that. And also there's been enormous amounts of investment in the AI, building up all this AI infrastructure. So how fast, and inference is where that's going to start making money. I've seen introduction of products like the CES show of everyone using AI in their products. So, going into the inference side of things. But is that going to give you a fast enough return versus the investment that's been made? Is there going to be some adjustment? Because it probably isn't. And if so, that's going to happen at some point. But it's not meaning that AI is going to go away. It just means that, there's going to be, there'll be another cycle, if you will.
So you mentioned CES, and I know there were quite a few product introductions there, and that was just a few weeks ago. Mm-hmm. What are the emerging technologies that you see coming out, whether they were just announced at CES or in that general time frame? What is new and coming that should be on folks' radar?
So again, at CES, the big emphasis is going to be on actually using a trained model, and that's what they call inference. And so there were a lot of examples of people coming up with using AI in consumer products. For instance, I went to visited LG, I visited Samsung. They would like to populate your kitchen and your house with their equipment, which all has AI attached to it, and they talk to each other. So
very different part of the Samsung business.
A very different part of the Samsung business than the memory side. So your refrigerator can keep track of how, the dates that you put stuff into it and whether it's getting close to its end of life. And if so, it will tell you about a nice recipe you can make with the stuff in your refrigerator and get your stove heated up for you to get it ready, right? So that's some of the stuff we saw. There's an awful lot of agentic type of AI that people are thinking of using for almost everything, from consumer uses to business uses. That certainly is going to be an interesting area of development. It has both opportunities and dangers associated with it, depending upon how you do it. And so those, I think, are going to be, CES is more than consumer products. There was much more than consumer applications that were being shown there. So I think that there's, like I say, whatever's going to happen short term, long term, I think there's going to be some benefits and new products and services that come out of AI, and it's going to change the way we work.
And so I saw some social media from CES. It looked like you're creating some new albums or something that I saw some cool album covers. Do we want to talk about that a bit?
So IEEE, I was president of IEEE in 2024. I've been an IEEE volunteer and a IEEE leader in several positions over the last 20, 30 years. And they had a booth at the at the CES show, and the booth was partly had an activity there, which was partly developing a song with AI about AI and your feelings about it, what you felt about it. But the other part of it was it took a picture of you, and then it would create an album cover and the song based upon your input for a particular musical genre. So the first one I did was, and I'll send you the pictures so you can.
I think Michael's going to put them in the B-roll too, so they might stream on top of this conversation.
I think they've got it because I put them in a LinkedIn post. So I did the first one. It's called Unintended Consequences. It was supposed to be a folk song. I was thinking Bob Dylan. It looked more like Glenn Campbell, the album they cover. And then I came back later on, and I'd been taking pictures all over the CES and stuff I thought was interesting. My phone was getting low on battery, so I came to the booth. I asked if they could help me charge it, and they did. And while I was there, I decided to play with the other genres. So That's when I generated all those pictures of different genres. It was pretty
super fun. It's fun to have fun with AI when we're also stressed about it.
I think it's good. I think if AI is used right, it'll be a great companion and a great tool and can augment human intelligence.
Absolutely.
And the AI I like to think about is augmented intelligence. That's our intelligence and I'd like to think of it doing that versus making it dumber. That's on just the facts side. The real challenge is what about longer attention spans, contemplative knowledge development, creativity? Will it be a spur or hurt that development? I think it can be a spur if we use it the right way, and it can give us more potentially. But we've seen this about every technology we've developed. You never get more free time. Will it give you more time to think about other stuff, the important stuff, and new and interesting and innovative stuff? We'll see. The jury's out.
Yeah. Used the right way. Absolutely. I'm sure that it can be accomplished. Okay. So as we tie up, I just wanted to highlight for folks where are good sources of information this year to keep their fingers on the pulse of what's happening. I'm going to call out a few things and please add. So technical groups working in this area, there's IEEE, of course. There's SNIA, who's doing a lot of really interesting work.
Yes, and I was recently appointed as secretary of the Compute Memory and Storage Initiative in SNIA.
Excellent, and that has a lot of different technologies that are a part of it for sure.
Indeed,
there will be something called Storage Developers Conference later this year, also in the Bay Area.
Yep.
Yeah, and that's really a technical conference where you can hear the latest from the technologists of what's happening. Very little marketing on top of it, and that's a great place to go. The FMS conference, Future of Memory and Storage, in August.
Be there.
Tom, be there, be square for sure. I think you can start buying passes already, if I'm not mistaken.
Right now we are, the registration is not open yet.
Okay.
Probably won't open until the beginning of April.
Okay.
But we are accepting the proposals for presentations right now. And that closes, at the end of February, excuse me.
Yes. Okay, great. And then, you publish data as you are able to, and you've been publishing a lot already in January. Where can folks find that other than in these show notes?
So I have a website, which is tomcoughlin.com. There's a tech paper which talks about me and stuff I do. There's a tech papers page where you can see some of the research that I do. That's things we sell that are available. I've also been writing a blog for Forbes.com on digital storage and memory and applications, and I do other writings as well. I've got a column on storage and memory with IEEE's Computer Magazine, but I do stuff, media and entertainment websites also. I write because I've been interested in that technology as well. So that's a little bit about some good places I think you can find out about this. And of course, there's all kinds of other conferences going on, but these are a few of the important ones and a few important sources.
Excellent. Tom, thank you for taking time out of your schedule. I know you get quite busy with a lot of travel and a lot of people tugging for your time. So thank you for jumping on this podcast. And certainly if folks are looking to engage with Tom, he goes to a lot of these events in person, and without being too forward with your time, I'm sure would enjoy you grabbing him after a talk or, if you bump into him in the hallways and say hello.
Thank you very much, Molly. And as always, it's a pleasure to work with you.
Thank you. Thanks for listening to Data Unchained, powered by Hammerspace. To learn more, visit hammerspace.com. If you have a guest you would like to hear on the show, email me at molly@hammerspace.com.